Hi everyone, how are you? Good morning. I, Rajesh Kumar, your physics teacher. Today we will discuss questions of Unit 1. We already discussed lots of questions. We will discuss some more questions today. So let's go. Yes. Question 1. What is the difference between angstrom and astronomical unit? Angstrom and astronomical unit both are the units of distances. 1 angstrom is equal to 10 to the power minus 10 meter and 1 astronomical unit is 1.496 into 10 to the power 11 meter. Okay, so next question. Define SI unit of solid angles. One steradian is defined as the angle made by a spherical plane of area 1 square meter at the center of a sphere of radius 1 meter. Next question. Name physical quantity whose units are electron volt and Pascal. Okay, electron volt is the unit of energy and Pascal is the unit of pressure. Okay, let's fill up the blanks. Okay, see, zero point 0.3 meter per second square. We need to convert it into kilometer per hour. So what we need to do? Okay, 3 into 10 to the power minus 3 upon 1 upon 3 3600 square. Then after solving this it will become 3.9 into 10 to the power 4 kilometer per hour, and the second part is 6.67 into 10 to the power minus 11 Newton meter square kilogram square. Need to convert it into gram inverse centimeter square second inverse minus 2. Okay, so convert it by putting the values. Okay, so you can solve out it is very easy to solve. 6.67 into 10 to the power 11, put the value of Newton, it is kilogram. Newton's value we need to find out, Newton kilogram meter per second square, then convert other values, and as we did in the part 1, similarly put the values and solve out this. Okay, so let's move further. Yes, when a planet X is at a distance of 824.7 million kilometers from the Earth, its angular diameter is measured to be 30.35.7 to the power 11 of arc. Calculate the diameter of X. Okay, R is equal to 8 824.7 into 10 to the power 6 kilometer. R is the radius of Earth. Okay, theta will be the angle subtended. Okay, then theta is equal to, need to convert it. Okay, radian per second it is, then convert it into radian. Okay, then we all know diameter L is equal to r theta, theta is equal to L by r. We all know this, and we, by putting the values, we can easily find out the value of L. So let's move further to question number 2. A radar signal is beamed towards a planet from the Earth and its echo is received 7 minutes later. Calculate the velocity of the signal if the distance between the planet and the Earth is 6.3 into 10 to the power 10 meter. Okay, x is equal to c into t by 2. Echo hertz, that means it will take, the time is twice, so we need to find out the distance first. Okay, c is equal to 2x upon t. C is the velocity of light, we all know. Okay, very easy to find out. If you are not able to solve this, then you can do only one thing. Just write the value of the speed of light over there. Next question. Find the dimensions of latent heat and specific heat. Latent heat, Q is heat energy, Q by M, it is heat energy upon mass. Latent heat energy formula is ml square T minus 2 upon M. It will become m0 L square T minus 2. Specific heat S is equal to Q upon M into Q. Okay, this Q upon M into Q. Then put all the values for of dimension formulas, and then we can find out the formula for specific heat. It is m0 L2 T minus 2 Kelvin inverse. Okay, in van der Waals equation, P plus A upon V square into V minus B is equal to RT. Okay, P is equal to A upon V square, A is equal to PV square, A is equal to F pressure force upon area into V square. Okay, so A is equal to, it is force mlt minus 2 upon L square into L cube, it is volume, its square is there. So the dimensions of A is m L to the power 5 T minus 2. Also B is equal to V. So V is equal to m 0 L cube T 0 over there. Okay. In question number 5, E comma M comma 1 I and G denote energy, mass and angular momentum and gravitational constant respectively. Determine the dimensions of E L square upon M square capital G square. Okay, let's find out the dimensions of the same. Okay, E is equal to ml square T minus 2. L is ml square T minus 1. M is equal to capital M. Dimensions, Z is equal to M minus 1 L cube T minus 2. Dimensions will be, after putting the values, what we will find out, it become a dimensionless quantity. Okay, all the dimensions in the numerator and denominator cancel out each other, so it become a dimensionless quantity. Let's move to the next question. Calculate the time taken by the light to pass through a nucleus of diameter 1.56 into 10 to the power minus 16 meter. Okay, so the speed of light is, we all know this, it is 3 into 10 to the power 8 meter per second. Now time is equal to distance upon velocity. We all know velocity is distance upon time, so we need to find out the time only over here. Let's put all the values. Then the time is 5.2 into 10 to the power minus 25 seconds. Okay, next question. Two resistances R1 100 plus minus 3 ohm, R2 200 plus minus 4 ohm are connected in series. What is the equivalent resistance? Okay, what is the equivalent resistance? So F is equal to mlt minus 2, A is equal to lt minus 2. Okay, question first, F is equal to ma. Okay, F is equal to ma. M is Fa inverse. Okay, then from equation 1, L is equal to at square. Okay, the dimensions of energy we all know, ml square T minus 2. Put the values in this. Okay, Fa minus 1 A square T 4 T minus 2 Fa T square it is. Okay, will be the final one Equivalent resistance is FAT square. Okay. Question number 8. If the velocity, time and force were chosen the basic quantities, find the dimensions of mass. Find the dimensions of mass. Then it is, we all know force is equal to mass into acceleration. Force mass into velocity upon time. Mass is equal to force into time upon velocity. Mass is equal to Ft upon V. It is Ft V minus 1. Okay, if we consider these as the basic quantity, that means as we consider mass, length and time in normal dimensional formulas. Next question is, a calorie is the unit of heat or energy and it is equal to 4.2 joule, where 1 joule is equal to 1 kilogram meter square second minus 2. Suppose we employ a system of unit in which the unit of mass equal to equal to alpha kilogram, the unit of length is equal to beta meter, and the unit of time is gamma seconds. Show that a calorie has a magnitude is equal to this, okay, in terms of new units. So the given that it is 4.2, 1 kilogram, 1 meter square, 1 second inverse minus 2. Let's move further. In new units, mass is equal to alpha kilogram. Hence, in terms of new units, 1 kilogram is equal to 1 by alpha. It is alpha inverse 1 meter, 1 by beta, beta inverse, or 1 meter square is equal to 1 beta minus inverse 2. And in terms of new units, 1 second, second inverse it will be 1 second square, it is 1 second inverse minus 2. 1 second inverse minus 2 will be equal to, reverse will be the powers, it is gamma square. In terms of calorie, put all the values, then it becomes 4.21 alpha, alpha minus 1, 1 beta minus 2, 1 gamma power 2. So it becomes, it is 4 alpha minus 1 beta minus 2 gamma up to the power 2. Okay. Explain this statement clearly. Next question. To call a dimensional quantity large or small is meaning without specifying standard for comparison. In view of this, reframe the following statement wherever necessary. Okay. Atoms are very small object. An atom is very small object in comparison to a saucer ball. Okay. Next is explanation part is, a jet plane moves with a great speed. A jet plane moves with a great speed greater than that of a bicycle. Next is, the mass of Jupiter is very large. The mass of Jupiter is very large as compared to the mass of a cricket ball. Okay. So next is, the air inside the room contains a large number of molecules. Then the air includes this room contains a large number of molecules as compared to the air present in the geometry box. Next is, a proton is much more massive than an electron. Okay, a proton is much more massive than an electron. Okay. Next is, the speed of the sound is much smaller than the speed of light. We all know this. Okay. Let's move to next question. Which of the following is the most precise device for measuring the length? A vernier caliper with 20 divisions on sliding scale. A screw gauge of pitch 1 mm and 100 divisions on circular scale. An optical instrument that can measure length to a within a wavelength of light. Let's find out which one will be the more precise. A division with minimum count is the most suitable to measure length. So, part A, least count of vernier calipers will be 1 standard deviation minus 1 vernier division. It is 1 minus 9 by 10. It is 1 by 10.01 centimeter. It will be least count of screw goes. It will also come out the same 0.001. Okay, not the same. Pitch upon number of divisions 1 by 1000. It is 0.001 centimeter. Least count of an optical device, wavelength of light, distance power minus 5 centimeter. Hence it can be inferred that the optical instrument is the most suitable device to measure the length. Okay, so answer the following questions. Let's study this. So the following questions. You are given a thread and a meter scale. How will you estimate the diameter of the thread? Okay, wrap the thread on a uniform smooth rod in such a way that the coil thus formed are very close to each other. Measure the length of the thread using a meter scale, and the diameter of the thread can be given by this relation. It is the length of the thread upon number of turn. Very good. You can easily find out it. Second is, a screw gauge has a pitch 1 mm 200 divisions on vernier scale. Do you think it is possible to increase the accuracy of screw gauge arbitrarily by increasing the number of divisions on the circular scale? But no, it is not possible to increase the accuracy of screw gauge by increasing the number of division on circular scale. Increasing the number of division on circular scale will increase its accuracy to a certain extent only. Okay, doesn't mean, well, if we continue to increase, then it increases the same in the given ratio. Okay, next is option C. The mean diameter of a thin brass rod is to be measured by vernier calipers. Why is a set of 100 measurements of the diameter expected to yield a more reliable estimate than a set of 5 measurements only? Okay, a set of 100 measurement is more reliable than 5 measurements because the random errors involved in the former are very less as compared to the later one. Okay, so let's move further. The mass of a box measured by a saucer balance is 2.300 kilogram. Two gold pieces of mass are added to the box. What is the total mass of the box? Let's find out. Okay, mass of saucer box is this, mass of first gold piece is this, second is this, the total mass will be this. In addition to the final result should retain as many as decimal places there are in the number of with least decimal places. Hence the total mass of the box is 2.3 kilogram only. We will remove or we will leave other smaller values. The difference in mass is this one. The difference in the mass of the pieces of the correct significant figure is, it is this one. In subtraction, and the final result should retain as many as decimal places as there are in the number with the decimal places, least decimal places. Next question. Okay, a physical quantity P is related to 4 observations A, B, C, D as follows. The percentage error of the measurement in A, B, C and D are 1%, 3%, 4% and 2%. Relatively, what is the percentage error in the quantity P if the value of P calculated using above relation turns out to be this? What value should be round off to the result? Okay, let's find out. delta P by P, it is 3 delta A by A plus 2 delta B by B plus 1 by 2 delta C by C plus delta D upon D. Okay, let's find out the percentage also. Multiply by 100 on left hand side as well as with each term on the right hand side. So it becomes 13%. The percentage error in P is 13%. The value of P is given this by rounding off the value to the first decimal. We find out P is equal to 3.8. Okay, got it? So let's discuss one more questions. The unit of length convenient on the atomic scale is known as an angstrom and denoted by this. The size of hydrogen atom is about zero point 0.5 angstrom. What is the total atomic volume in m cube of a mole of hydrogen atom? The radius of hydrogen atom is equal to 0.5 angstrom. It is 0.5 into 10 to the power minus 10 meter. Volume is 4 by 3 pi r cube. We all know the formula of volume. Okay, so put the values of r in this particular formula. 4 by 3 into pi, 22 by 7 into 0.5 into 10 to the power minus 3 to the power 3. So it becomes, this value is 0.0524 into 10 to the power minus 30 meter cube. 1 mole of hydrogen atom contains 6.023 into 10 to the power 23 hydrogen of atoms. So the volume of 1 mole of hydrogen atom is this one, and it becomes, after cancel out or solving the term, it is 3.16 into 10 to the power minus 7 meter cube. Okay, got it, dear students? So today we discussed around 15 questions in this class, and rest of the questions we will discuss in our next class. So till then, try to understand and solve these questions, and if you face any difficulty in any of the questions, you can ask to me. You are free to ask, and your suggestions are also valuable. So do your work with full of your energy and try to focus more and more and enjoy your day, dear students. Okay,